In this video we're going to run through the Edexcel GCSE Maths Syllabus B Unit 3 paper from November 2013. Question 1 is looking for a type of transformation. There are 4 types of transformation. We've got reflection, rotation, translation and enlargement. It's not a translation because it seems to be facing the other way. It's not a rotation because it's not simply being rotated, otherwise this, instead of being a shape like this, it would be a shape like this somewhere. So it's not a rotation, so that leaves an enlargement or reflection. I mean, to be honest, this basically looks like a reflection. If you draw lines from corresponding points on P and Q, they will go through the line of reflection at 90 degrees, and the line of reflection will be halfway between those 2 points. So here we are, the y-axis, or the line x equals 0, will be our line of reflection. So we need to state both of those things. It's a reflection, and we need to give the equation of the line of reflection, or simply state that it's the y-axis in this case. Part B asks us to rotate the triangle 90 degrees in the clockwise direction around this centre of rotation here. So first thing is, let's label up the centre of rotation. So 0, 2. Now I always find it's a good idea to just draw a straight line from the centre of rotation to one of the vertices. Now that thing is going to rotate 90 degrees in the clockwise direction, so that line would rotate to this position here. So we know that this point on the original shape is going to rotate to here. And from that we can work out the rest of the shape. There we go. Obviously that's easier if you've got a nice big piece of tracing paper which you can pivot at this point here, draw the original shape on, and then swivel it round 90 degrees in this direction, and you'd see it lining up here. So always ask for a piece of tracing paper in the exam if you're trying to do a rotation. So this is a percentages and fractions proportion question. So one day Supermarket's got 8,420 customers, 65% of them pay with a debit card, a fifth of them, that's 20%, pay with credit card, and the rest pay with cash. So in total we've got 65 plus 20% is 85% of them are paying with either debit cards or credit cards, so the rest must be the other 15%. So 15% literally means 15 out of 100, percent is Latin for out of 100, so 15% of 8,420 people is 1263. If another way of looking at this is 15 divided by 100, which is 0.15. So this is called the multiplication factor. So we could also do the calculation 0.15 times 8420, and we get the same answer. So put your answer in a nice big box, make it nice and clear, easy for the examiner to see what your final answer is. These trial and improvement questions are very easy to lose marks on, so you really do need to follow the method quite closely. I'll explain later where most people lose 1 or 2 marks. So we're going to start off by writing a table for our results. The first column, x, is the values that we're going to try and improve. The second column, x cubed plus 4x, this is the expression that we're trying to evaluate and try and hopefully get a value of x which gets us close to 60. We've then got a column for comments about the results, and finally you don't have to use the range column, but I find this quite useful and you'll see this in action in a moment. So first of all, let's try 3 and 4 in this expression and see what answers we get. So firstly try x equals 3, so 3 cubed plus 4 times 3 is 39. Well, that's too small. We were hoping for 60, we've got 39. So it tells us, because we've got a positive x cubed and we've got a positive 4x, it tells us that the final solution must be x is bigger than 3. And when we try 4 cubed plus 4 times 4, that gives us an answer of 80. That's too big, that's bigger than 60, and we now know that the answer must be between 3 and 4. So let's try another value between 3 and 4, let's try 3.5. And 3.5 cubed plus 4 lots of 3.5 gives 56.875. That's still too small, and so we now know that if we have a value of 3.5 it was too small, 4 it was too big. So somewhere between 3.5 and 4 is where our proper answer is. So we've moved in the left-hand end of our range of possible values. We now know it's between 3.5 and 4. So I'm going to try 3.6, and we find that the answer is 61.056. Well, that's just a little bit too big, so now we've narrowed in between 3.5 and 3.6 as being where the answer lies. And this is where lots of people start to lose marks, because they start trying to guess which one of these two answers is closer, so whether 3.5 or 3.6 is the nearest answer. But that's really not the method we've got to use. So 3.5 gave us an answer which was too small, and 3.6 gave us an answer which was too big. So somewhere in between 3.5 and 3.6 is the actual answer. So what you need to do is try 3.55. So halfway between 3.5 and 3.6. If the answer is too small, then we know that the proper answer will have been between 3.55 and 3.6. And if the answer is too big, we'll know that the answer will have been between 3.5 and 3.55. That'll tell us whether the actual value of x is closer to 3.5 or the value of x is closer to 3.6. So let's try that now. And when we do that, we find that it gave us an answer which was too small. 58.93 is less than 60. So what we're going to do is, we know that 3.5 was too small, 3.55 was too small, so somewhere in between here and here, in between these two numbers, is where our answer is just the right size. So if it's to the if it's to the right of 3.55, it must be closer to 3.6 than it is to 3.5. So there we have it, to one decimal place, our answer is 3.6. So the crucial point where people lose marks is that they don't do this halfway point between the two consecutive answers they get to one decimal place. They try to shortcut the method by working out which answer was closer, as in which result in evaluating the expression was closer. But what we're looking for is which version of x, which value of x is closer. So we have to do this extra step here. In question 4, we've got a piece of pipe which is 150 centimetres long, which weighs 800 grams. We want to cut a piece which is only 90 centimetres long, so if we sort of chop it off about here, that's 90 centimetres from here to here. We can see that what we've got is 90 of the 150 centimetres of the pipe. So the proportion of the pipe that we're interested in is 90 150ths, and that same proportion of the weight, assuming it's evenly distributed along the pipe, which is all we can do, will be the weight of the new piece of pipe. So that's 480 grams. The best way to tackle question 5 is a bit of algebra. So let's let P equal the price of a purse and K equal the price of a keyring. So because the price of a purse is twice as much as the price of a keyring, the value of P must be twice as big as the value of K. So if we get 8 lots of the P price and 9 lots of the K price, we've said here that that's got to equal exactly £40. So the price here is in pounds and the price of K is also in pounds. But because we know that P is equal to 2K, we can actually use that and replace the P here with 2K. And that's great because we've now got a linear equation with just one unknown in it which we can solve. So 16K plus 9K is equal to 40. In other words, 25 lots of K is equal to 40. And if we divide both sides by 25, we get K is equal to 40 over 25. So the price of a keyring is £1.60, and the price of a purse is twice the price of a keyring, which is £3.20. So if you get chance, it's always a good idea to check that out. 8 times £3.20 plus 9 times £1.60, when you put that into calculator, that it does indeed equal 40, so we know for sure we're right. So finally, let's make it really nice and easy for our examiner to see the answer. Rather than using variables like P and K in our answer, let's stick with the actual words. Purse is £3.20 and keyring is £1.60. Question 6 takes a little bit of organisation. First of all, let's read the question. So Mrs. Evans goes to the zoo on Friday the 17th of July, that's this date here, which is in the off-peak season. She's got 1 adult and 3 children, so for off-peak we're looking at these prices over here. So having highlighted those, let's have a look here. She wants to buy the tickets as cheaply as possible. She's entitled to the 10% discount because she's got 1 adult and 3 children. So that's the calculation we're going to have to do. So before we work out the discount, it's 1 adult at £19.50 plus 3 children at £15, which gives us a total of £64.50. Now, to apply the 10% discount, that leaves us with 90% left to pay. So we can either do 90%, 90 hundredths of £64.50, or, if you're familiar with the multiplier, 90 divided by 100 is just simply 0.9. Either way, we get the same answer, £58.05, so we need to make that as clear as possible for the examiner. Make our final answer nice and clear as possible. One word of advice on these money questions: if in this case we've got £58.05, so that's a pretty obvious amount to write, but if it had been £58.50, we would have lost marks for just writing 58.5. We would have lost a 1 mark for that, because money either has to be to no decimal places or 2 decimal places. So just watch out for that sort of question in the future. Obviously that's not the answer here, so we're not interested in that. So in question 7, we've got a new school's going to be built, and we've got to do with a scale drawing. So we've got to find something that is less than 5 kilometres from Alford, so we're going to draw a circle. Looking at the scale, 1 centimetre is 1 kilometre, so the radius of that's going to be 5 centimetres. It's got to be inside that circle, and it's got to be nearer to Bancroft than it is to Alford, so we've got to try and find the dividing line, which is equidistant from Bancroft and Alford. So we open up the compasses over halfway between the two, put the point on Bancroft, and then draw a nice arc going all the way around that way. Now, keeping the compasses exactly the same distance open, which is very important, point on Alford, and again a nice big arc going all the way around. Now, every point on that arc is the same distance away from Alford. Every point on the other arc is exactly the same distance away from Bancroft. So this point here and this point here must be the same distance from Bancroft as they are from Alford. And if I join those two lines up, so pencil on the paper first, bring the ruler up, swivel it into position, check my point there, and then draw a line going straight down the middle. Everything on this side of the line is closer to Bancroft than on this side of the line. Next, we need to, using a scale of 1 centimetre, representing 1 kilometre. New school is less than 5 kilometres from Alford, so that's 5 centimetres on our map. So let's get the ruler in, point on here, adjust that down to exactly 5 centimetres. Now we can draw a circle radius 5. So everything inside here, inside this circle, is within 5 kilometres of Alford, but everything this side of the line is closer to Bancroft. So what we're looking at here is this region here. You don't have to shade it right in, just a few lines going all the way across to indicate that region will tell us this area here matches both of those criteria. Question 8 has got an asterisk, which means it's a functional skills question, and you really do have to show you're working out to get many marks at all. The two basic approaches are either working out how many pence per millilitre it will be, or how many millilitres per pence or per pound you would get. So show your calculations for either of those. I'm going to show both. So to convert to pence per millilitre, if I get 70 millilitres for 179 pence, if I divide that by 70, that'll tell me what 1 millilitre costs. So 2.557 pence for 1 millilitre, 2.75 pence for 1 millilitre of version 2, and 2.66 pence for version 3. So clearly this is the cheapest rate per millilitre. On the other hand, if we're doing millilitres per pounds, we can see with the first one that I get 70 millilitres for £1.79. So if I divide by £1.79, that'll tell me how many millilitres I get for £1, which in this case is 39.106 ... millilitres. And in this case, we're looking for the most millilitres we can get per pound, which again is the first one. So our answer is version 1, the 70ml tube, because that's the cheapest rate per millilitre. In question 9, we've got a nice quadratic equation. We've got to complete a table of values for this particular quadratic here. We're given some value to start off with, and then we've got to draw the graph. So we're looking for the x squared value. We're then taking away 5 lots of x, and then we're adding 3. So let's do the first one first. So we're looking for minus 1 squared minus 5 times minus 1 plus 3. Well, minus 1 squared is 1, minus 5 lots of minus 1 is plus 5, plus 3 is 9. So the answer here is 9. For 2, we're looking at 2 squared minus 5 times 2 plus 3. 2 squared is 4, 5 times 2 is 10, so minus 10, and then we're adding 3. 4 take away 10 is minus 6, plus 3 is minus 3. And for 4, we're looking at 4 squared minus 5 times 4 plus 3, 16 minus 20 plus 3. 16 take away 20 is minus 4, plus 3 is minus 1. And I guess the clue here is that when we plot these, we know that a quadratic should be either a nice happy curve or a sad curve. In this case it's going to be a happy curve, but it needs to be symmetrical. So for part B, let's draw the graph of those. So first of all, minus 1, 9, minus 1, 9, that's going to be up here. 0, 3, 0, 3, that's going to be here. 1 minus 1, here. 2 minus 3, that's down here. 3 minus 3 is down here. 4 minus 1, it's back up here. And 5, 3, that's up here. So we do have this symmetrical part of the curve. Obviously it's going to go off in that direction and it's going to go back up here again. Now what I'd strongly recommend that you do here is turn the paper around and actually use the natural arc in your hand to draw these. So let's kind of go up like this. Now it's going to peak down here somewhere and come back up here and then go back up through here, up to here and off. Part C asks us to estimate the solutions of that equation being equal to 0. Now if we go and solve this using the quadratic formula or completing the square or something like that, we haven't done an estimate because we've calculated an actual solution. So what we need to do here for our estimate is to go back to the graph and to just read off some values. The graph that we drew earlier was y equals x squared minus 5x plus 3, and we've been asked to find solutions to x squared plus 5x plus 3 equals 0. So this bit is equal to this bit. In other words, what we're looking for is when does the y coordinate equal 0. So if we draw the line y equals 0 on the graph, and we're looking for where does our curve cross the line, y equals 0, and we're looking here, and we're looking here. So the y coordinates on that line are 0 when x is 0.7 or x is 4.3. There's a bit of leeway because this is an approximate solution. So long as you've read it accurately from your graph, these are roughly the right answers. Question 10, bit of algebra here. We're expected to show our working out for 2 marks over here. So first of all, we're going to multiply out the brackets. 4 lots of y are 4y, and 4 lots of negative 7 are negative 28, and that's equal to 13. So I'm now going to add 28 to both sides of my equation to try and get rid of 28 from the left hand side. So 4 lots of y are equal to 41, But I want to know what 1 lot of y is, so I'm going to divide both sides by 4. And of course 41 divided by 4 is 10.25. That would be my answer. Write that over here, 10.25. Part B is also testing my algebra skills, so I've got to make t the subject of this formula. Well, first of all, I don't like the minus 3 on that side, so I'm going to add 3 to both sides, which leaves me with just 4t on the right hand side and p plus 3 on the left hand side. Well, now I've got 4 lots of t, so I'm going to divide both sides by 4. But of course I have to divide the whole of the left hand side by 4 in order to get the right answer, and just t on the right hand side. Obviously there are different ways of presenting that final answer, but there we go, t is equal to p plus 3 over 4. An important point here is to make sure that you leave your p as a capital P and you leave your t as a lowercase t, because that's how they were presented in the question. You shouldn't really change those. Question 11 is a trigonometry question, so let's write down our triangles. O'Shane, Actu, Otar. Right, now given that we're interested in angle y, in relation to that, this side here is the hypotenuse, this side over here is the opposite, and this side over here is the adjacent. We haven't got any information about the hypotenuse, but we are interested, or we do know about the opposite side, and we do know about the adjacent side. So we're looking for the O and A ratio, which is OTAR. And what we're trying to find out is the tan of the angle. So if I cover up T, the tan of the angle, we're left with O over A. So T equals O over A, which is 86 over 37. In other words, tan of Y is equal to 86 over 37. So if tan of Y is 86 over 37, then tan to the minus 1 of 86 over 37 must be equal to Y. And making sure that your calculator is in degree mode, type that into the calculator and you find that Y is equal to 66.721058. But of course the question asks for us to give our answer to 1 decimal place. So let's write that over here, nice and clear. Y is equal to 66.7 degrees. Don't forget to write the units because they are degrees because it's an angle. Question 12. We've got some inequalities to deal with. So always with inequalities, what we do is we try to rearrange them to make standard lines, and then we work out which side of the line we are. So the line x plus y is less than 6. We're going to rearrange this. I'm going to subtract x from both sides, so I've got y is less than minus x plus 6. And then we're okay with the other two. So I'm going to draw, first of all I'm going to draw the line y is equal to minus x plus 6. This has a gradient of minus 1 and cuts the y-axis at plus 6. So it cuts the y-axis here, has a gradient of minus 1. So every time I go along 1, I go down 1. So this is the line y equals 6. Y equals minus x plus 6. Now, because this is a less than, I'm actually going to do this as a dotted line, because points on the line are not included in that region. If that was a less than or equal to, I'd have drawn a solid line, because points on the line are included. Now we want to draw the line x equals -1, so the x coordinate is always equal to -1. Again, I'm going to draw this as a dotted line, because points on the line are not included. And finally, we're going to draw the line y equals 2. And again, it's going to be dotted because this is not greater than or equal to. Okay, so we've got y equals 2, we've got x equals -1, and we've got y is less than minus x plus 6. Now, for x equals -1, okay, we want the x coordinates to be bigger than that -1, so we want the x coordinates to be on this side of the equation. So I'm going to actually shade out the other side, because that's the region we don't want. The y coordinates have to be bigger than 2, so I'm going to shade out this region because that's the region we don't want. Shade those ones out. And the y coordinates need to be less than minus x plus 6. Now on that line, the y coordinates are equal to minus x plus 6. So we want the y coordinates to be less than that, to be lower than that. So I'm going to shade out the region above the line because that's the region we're not interested in. Let's get rid of that lot. So this leaves this region inside here, not including the lines. I can mark that with an R because that's what it asks us to do. Mark the region with the letter R. This side, this region in here, is the correct region. In question 13 we're given a diagram, not drawn to scale, and we've got to work out the perimeter of trapezium DECB. So we already know that the top is 5 centimetres and this side here is 6, so we've got to work out the length of BC and the length of EC. Angle A up here is common to both triangle ABC and ADE. Angle ADE is the same as angle ABC because they're corresponding angles because of these parallel lines DE and BC. And angle AED is equal to angle ACB again because they're corresponding. We've got this transversal AC crossing parallel lines DE and BC. So this means that triangles ADE and ABC are similar triangles. In other words, the corresponding sides are in the same ratio. So looking down this side here, the ratio of AD to AB, the big triangle, ratio between the lengths of the sides of the two triangles, is 4 to 10. So 10 divided by 4 is equal to 2.5. This means that I have to multiply the small length by 2.5 to get the big length. In other words, the scale factor from the small triangle to the big triangle is 2.5. I can use this fact to work out some other lengths. So for example, to work out the length BC, I need to multiply DE by 2.5, which gives me an answer of 12.5 centimetres. And the length AC, the big length down here, would be 2.5 times the length of AE here. So that's 2.5 times 5.8, which is 14.5 centimetres. But obviously I'm really only interested in the length EC, so I've got to take away 5.8 from that 14.5 in order to find out how long EC is. So now I've found out the lengths of all the bits of the trapezium that I'm interested in, I can add them all together to find out the final perimeter. And when I add them all together, I get 32.2 centimetres. For question 14, we've got to solve these two simultaneous equations. Let's call them equation 1 and equation 2. Now, we've got to try to eliminate either x or y, or we can use substitution. I'm going to use elimination in this particular case, so I'm going to multiply everything in equation 2 by 5 so that I've got positive 5y, and then I can add those equations together. Alternatively, I could have multiplied everything by 3 in equation 1 and everything by 4 in equation 2, and I'd have had the same number of x's. So let's see what happens here. Well, firstly, by multiplying everything by 5 in equation 2, my new equation, equation 3, is 15x plus 5y is equal to 5. Now I'm going to add equations 1 and 3 together. And when I do that, 4x plus 15x gives me 19x, minus 5y plus 5y means I've got no y's, so I've eliminated y, and 33 plus 5 is 38. Now, divide both sides by 19, so I can work out that 1x is equal to 2. If I substitute this value into the original equation 2, I see that 6 plus y is equal to 1. If I subtract 6 from both sides of that equation, I've now got y is equal to minus 5. Don't forget to make your answer nice and clear on the page. Ideally, put it in a big box at the bottom so we can see what's going on. At the end of the paper, if you've got time, you can always come back and check your answer. So just looking back to equation 1, up here, 4 lots of 2, the value we had for x, minus 5 lots of minus 5, the value that we had for y, gives us 8 plus 25. Obviously minus 5 times minus 5 is plus 25. That's 33, and that is exactly what we're expecting in equation 1, so we know that we're correct. The key to getting question 15a correct, the first part, is if your calculator doesn't allow you to enter this calculation in this exact format, then make sure that you get brackets around the relevant bits here. So the 46.2 minus 17.5 needs to be done inside that square root, and then the whole of that needs to be divided by the whole of the denominator. So I get 3.202174593. So giving our answer to three significant figures, we're looking at the first three figures, so we're sort of hiding everything after the 3.20, but then we have a little sneaky peek at the fourth figure, which is a 2, so that's less than 5, so we keep that at 3.20. If that 2 there was a 5 or more, then we would be rounding this up to 3.21. Again, some of you will have calculators that will handle the final part really easily. For others, you may need to consider the calculation in two parts. We can rewrite it in a different order. This is effectively 2.34 times 5, and then we can multiply that by 10 to the 5 times 10 to the 4, which gives us 11.7 times 10 to the 9. 10 to the 5 times 10 to the 4, we're multiplying that by 10 9 times. But for standard form, obviously the first number here needs to be between 1 and 9.9999 recurring. So let's adjust that if we can. And obviously 1.17 isn't the same as 11.7. I'd need to multiply that by 10 to the power of 1. So this number down here is now the same as this number up here. And then the answer needs to be multiplied by 10 to the 9. So our final answer for that one is 1.17 times 10 to the power of 10. As I say, this one really, in calculators, you shouldn't really need to do all of this. You just type the number straight in your calculator, it will give you your answer. But on a paper 2, a non-calculator paper, you might have to do this thing and show you're working out in this kind of format. So in question 16a, we've got a triangular shaped flower bed. In fact, it's an equilateral triangle. So all the angles are 60 degrees, and given that the perimeter is 15 and all the sides are the same length, all the sides are 5 meters long. So we're going to use area is a half AB sine C, because we've got two adjacent sides and an enclosed angle. So two sides, doesn't really matter which ones we choose, and the enclosed angle here, so a half times 5 times 5 times sine of 60 gives us 25 root 3 over 4 square meters. Now the question is asking for one decimal place, so we need to convert that into decimals and then to round it, which to one decimal place it's 10.8, the next digit's only a 2, so we don't have to round up, giving us our answer of 10.8 square meters to one decimal place. In part B of the question, we've got some flower pots which are hemispheres, and we need to work out how many of these hemispheres we can fill up with 80 litres of compost. So the volume of a sphere would be 4/3 pi r cubed, so the volume of a hemisphere is a half of 4/3 pi r cubed, and the radius of our pot is 17.5 centimetres. So let's write the calculation down. And if we leave the answer in terms of pi, that's a nice accurate answer that we can work with for the rest of the question, so we don't lose any accuracy. Now 80 litres of compost is 80 times 1,000, so that's going to be 80,000 cubic centimetres of compost that we've got, so we've got to see how many times that goes into that. So the calculation is 80,000 divided by 42875 pi over 12, or just over 7 pots. So the answer to the question is that she can completely fill 7 pots. Now some slightly tricky algebra in question 17. We've got to make x the subject of this particular formula. And obviously x is in the denominator on the right hand side, and x is also in the numerator. We've got x squared, so not an entirely trivial exercise. The first step is to multiply both sides of the equation by x squared minus 7. which is the denominator over here. I would also make sure that I write the numerator and the denominator in brackets there to make sure all the relevant things are kept together. So if I multiply both sides by x squared minus 7, obviously on the right hand side those two are going to cancel out to give us this. So now I'm just going to multiply out the brackets on the left hand side. And the general aim here is to get all the x's over on the left hand side on their own, and then everything else onto the right hand side afterwards. So I'm going to start clearing out the left hand side by adding 7y to both sides. So obviously if I start off with negative 7y on the left hand side and I add 7y, I've got no y's on the left hand side, which was the point of doing that. Next I'm going to subtract x squared from the right hand side and the left hand side, which clears my x squareds from the right hand side. In fact, I've got rid of x altogether from the right hand side now. So I can factorise the left hand side, take the x squared out as a common factor. So in the first case I'd have to multiply x squared by y to get yx squared, and in the second case I'd have to multiply x squared by minus 1 to get minus 1x squared. Now I can divide both sides by y minus 1. So divide the left hand side by that. Divide the right hand side by that, and again they'll cancel out on the left hand side. So we're nearly there now. I've just got the x squared to deal with, so I obviously need to square root both sides of the equation to get what x is equal to. If I square root x squared I get x, and if I square root the right hand side, it's important to square root the whole of the right hand side, but also that could be a positive or a negative value. You're not actually going to lose any marks on this particular question if you don't put the plus or minus in, but generally speaking, the square root of 16 could be 4, it could be minus 4, so there should be two solutions to that particular problem. So this would be my answer here. Obviously I may have organised things slightly differently. If I've on the numerator on the right hand side here I've got 7y plus 9, that's equivalent. There are different variations on a theme, but that's the general principle for that question. Question 18 is an asterisk question. In other words, the explanations and the reasons that you give for your answer are going to be crucial to you getting full marks on this question. Well, first of all, we can observe that A, B, C, D is a cyclic quadrilateral. So let's write that. And that simply means that all the vertices A, B, C and D make up a quadrilateral, and the vertices are all on the circumference of the same circle. Now we also know that opposite angles in a cyclic quadrilateral add up to 180 degrees. And that means that this angle plus this angle equals 180 degrees, so we can now work out what that angle is. So 180 minus 116 gives us 64 degrees. We also know that the angle at the centre is twice the angle subtended on the circumference. This is one of our circle theorems. Now when you write that, please try to use the right words. You make it so much easier for the examiner to give you full marks if you use proper words like subtended and quote the proper circle theorem rules. Now that rule means that x is twice as big as 64. 2 times 64 is 128 degrees. So let's write our answer here, nice and big, x equals 128 degrees. So question 19 is a vector question. We've got vector A, which goes in that direction, and when we write it in handwriting we do an A underlined because we can't do the bold that they've used in the question. And vector B obviously is going in this direction by this amount, and we're going to call that vector B. So line OA is for the journey from O to A, and line OB is the journey from O to B. So in this question we've got to map out the journey from A to B. So to get from A to B we can go this way, or we could go back this way and down this way. Now obviously if we go the first way we haven't got any other vectors by which we can measure that, but if we go backwards along A, that's effectively minus A, and then we go forwards along B, that's positive B. We're going to get from A via a slightly circuitous route, but we're still going to end up at the same place, B. So our answer is minus A plus B. In the second part of the question we've got to get from O 2x. And the way we can do that is we can go from O to A and then from A to X. So that would be our journey. So we know we've got to start off by going along that direction by vector A. So we've just got to work out how do we represent AX. Well, the ratio of the distances from A to X and X to B are 1 to 4. So in other words, this journey comes in 5 parts, the first part of which is the journey from A to X. That is a fifth of the total journey from A to B. Now in part 1 of the question, or part A of the question, we found an expression that would get us from A to B. So what we're going to do here is simply add the A that gets us from O to A to a fifth of the vector that took us from A to B, which will take us a fifth of the way. So the journey from O to X is the journey from O to A plus the journey from A to X, and the journey from A to X is a fifth of the journey from A to B. So that is A plus a fifth of minus A plus B. And then multiplying out those brackets there, a fifth, so it's A minus a fifth of A plus a fifth of B, which is equal to, final answer of 4/5 of an A plus a fifth of B. In question 20, we've got a fairly difficult bit of factorisation because we've got to factorise a quadratic that's got a coefficient of x squared which is not 1. So we're going to have to use a particular method, or one of the best ways is this particular method that we're going to use here. So what I'm going to do is multiply the coefficient of x squared by the number on the end, minus 216, and then I'm going to try to find the factors of 216, or negative 216, which multiply together to make 216, but add together to make negative 30. Now, obviously, I'm trying to multiply them together to make negative 216, so one of these numbers has got to be positive, and one's got to be negative. So looking over here at 6 and 36, if I make then 36 negative, 6 add negative 36 will give us negative 30x. So I'm going to rewrite that minus 30x as 6x minus 36x. So what I've written is entirely equivalent. 6x take away 36x is the same as minus 30x. And by the way, it wouldn't have mattered if I'd have written minus 36x plus 6x, I'd still get the same answer at the end of the day. So I'm going to factorise the first two terms, and then I'm going to factorise the second two terms. So looking at this, 8x squared and 6x, I can take out 2x as my common factor. Now 2x times 4x would give us 8x squared, and 2x times positive 3 would give us the 6x. Now it's important that this term here, this thing in brackets here, 4x plus 3, is a common factor between these two things. So I'm going to write that down and then just work out what do I need to multiply that by to get the terms I've actually got up here, minus 36x and minus 27. So what do I need to multiply 4x by to get minus 36x? I need to multiply by minus 9. And if I multiply 3 by minus 9, I get minus 27. So that's good. Now, I've got 4x plus 3 as a factor in both of these terms. So I'm going to put the 4x plus 3 at the beginning. Now in the first case, I've multiplied 4x plus 3 by 2x. And in the second case, I've multiplied it by minus 9. So that's going to give me my second bracket. So now I've factorised, so we've done the first part of the question, we've factorised the expression. So we've got two things multiplied together to make 0. Now the only way that can happen is if one of these two things is 0. So either 4x plus 3 is equal to 0, or 2x minus 9 is equal to 0. If it's 4x plus 3, then if I take away 3 from both sides, I've got 4x is equal to minus 3. And then if I divide both sides by 4, I've got 1x is equal to minus 3 divided by 4, or minus 3/4. So that would be my first answer. If it's the second one, then if I add 9 to both sides, I've got 2x is equal to 9. Divide both sides by 2, I've got x is equal to 9 over 2. And that's my second answer. So finally, x is equal to minus 3/4, or x is equal to 4.5.